Hi folks, this is Checkpoint Quiz 8.4. We're given a system of linear equations, which is actually the same system we had back in Checkpoint Quiz 8.2. We're asked to solve this system using a matrix inverse. Okay, so how do we do that? Well, what we do is we rewrite this system of linear equations as a matrix equation. So we let A be the coefficient matrix. So once again, that's just a matrix we get by looking at the coefficients in the variables, each row corresponding to an equation. So for the first row of the matrix is just the coefficients for x, y, and z, 3, 2, 1. The second row we got the coefficients 1, negative 1, 3. And the third row is 2, 5, negative 11. So that's the coefficient matrix. And then we have the mystical unknown matrix X that stores the unknowns, the variables, X, Y, Z. And then we have the constant matrix B, 1, negative 3, 8. And so we have that the system of equations up here is equivalent to the linear matrix equation AX equals B. And from Algebra 1, we know if we had an equation like this, we would quote-unquote divide both sides by A to get the answer X. And what we're going to do is multiply then both sides by the inverse of the matrix A to solve it. So if A is invertible, so if A inverse exists, we can get this as A inverse B for our answer. So once we find the inverse, we multiply it by the matrix B, and then we're on our way. Okay, so the first big step then is finding the inverse of this matrix A. So let's review how we go about trying to find that. The method we have is we're going to put A in 1/2 of a super deluxe augmented matrix and put the identity in the other half. And then we're going to do our usual row operations, the row ops, and use Gauss-Jordan Elimination. And if A has an inverse, I'll be able to transform A into the identity. And then doing so, we're going to keep track of all those row operations over here, and whatever we get over there is going to be the inverse matrix. Alright, so it's time to go in and do the Gauss-Jordan elimination. Okay, so hopefully by now the algorithm here is old hat, but the first thing we need to do is we want to get a 1 in the upper left hand corner. So there are lots of different ways to do that, but the easiest is to switch row 1 and row 2. So that's step 1, is switch row 1 and row 2. So I've got 1, negative 1, 3, 0, 1, 0, 3, 2, 1, 1, 0, 0, 2, 5, negative 11, 0, 0, 1. And now that I have a 1 up here, I want to use elimination to zero out what's underneath it. So what I'm going to do that is I'm going to replace the row 2 I have with negative 3 row 1 plus row 2. Replace row 2 with negative 3 row 1 plus row 2. And I'm going to replace row 3 with negative 2 row 1 plus row 2. Alright, so row 1 I'm keeping as is. For row 2, I take negative 3 times each of these numbers and then add it to row 2, and that's the new row 2. So I take negative 3 times 1 is negative 3, add that to 3, you get 0. Negative 3 times negative 1 is 3, add that to 2, you get 5. Negative 3 times 3 is negative 9, plus 1 is negative 8. Negative 3 times 0 plus 1 is 1. Negative 3 times 1 plus 0 is negative 3. And get 0 there. Now for the new row 3, I multiply each of these guys by negative 2 and add them to the corresponding entry down here. So negative 2 plus 2 is 0. Negative 2 times negative 1 is positive 2. Add that to 5, you get 7. Negative 2 times 3 is negative 6. Add that to negative 11, you get negative 17. Negative 2 times 0 plus 0. Negative 2 times 1 plus 0. And negative 2 times 0 plus 1. So now I've got the 1 with zeros underneath it. Now I want to get a 1 in this position. And I'm going to, this is a negative 8, and I want to make it look like a negative 8 so I don't mess that up here. Okay, so there's no quick way to get a 0, 1 here. I'm just going to have to divide this row by 5. So I'm going to replace row 2 with row 2 divided by 5, or 1/5 row 2. It amounts to the exact same thing. So I have 1, negative 1, 3, 0, 1, 0 for row 1. I multiply everything in here by a fifth. 0 times a fifth is 0. 5 times a fifth is 1. Negative 8 times a fifth, negative 8 fifths. 1 times a fifth is 1/5. Negative 3 fifths. 0. And then 0, 7, negative 17. 0, negative 2, 1.